Do you remember these things? Well, a few brave, intrepid individuals have asked me to explain how the coding for these things works. The recursive nature of this coding is not easy to understand. So before you start, get the headache tablets ready. I reckon you will need an IQ of at least 150 to understand it. The actual code text is in the message box below this video. I suggest that you print a copy to follow as the video proceeds. In a nutshell, the program relies on the updating and management of a stack of values and a subroutine that continually calls itself until a value, a circle diameter in this case, goes below a certain value, a value of 1 in this case. Let's start at the beginning of the code. Lines N020 and N030 set up my CNC machine. Line N040 prevents the motor turning. This is required on my setup since the pen is held in the motor collet. We do not want the pen rotating at 3200 RPM. The parameters 1 to 4 are initialized with the starting values. Parameter 5 is loaded with the scale parameter so that the drawing will fit on the paper size, A3 in this case. Parameter 6, like one of my back molars, is missing. Parameter 7 is loaded with the recursion angle increment of 120 degrees. Parameter 8 is the recursion reduction factor. And parameter 50 holds the value of the stack base. See the Excel stack diagram on the left hand side of the video. Okay, that's the easy part. At line N180, the value of parameter 1 is loaded or pushed into the parameter at #50, which first time around is #1000. So #1000 or parameter 1000 is loaded with 0. At line N190, the value 1 is added to the value in #50. So #50 will contain the value #1001. In other words, the stack pointer is increased by 1. Then at line N200, the value in #2 is loaded into the parameter #50, which now contains #1001. So 1001 is loaded with 0 also. We repeat this process at lines N210 to N250 and the result is #1002 contains 64 and #1003 contains 0. This is a standard technique in assembler coding for preserving parameter or register values when a subroutine is invoked or called. It means that when the subroutine returns, the values can be reclaimed by popping them off the stack and decrementing the stack pointer. This is shown in lines N280 to N350. Notice that the stack pointer is decremented before a value is popped off the stack. This is the exact reverse of when the values were pushed onto the stack. At line N270, the subroutine 0112 is entered. This is where it gets a bit difficult because after it does some simple calculations and draws a circle at N410 to N420, it then repeatedly calls its calling subroutine, which recalls itself until the diameter of a circle held in parameter 3 becomes less than 1 by virtue of line N260. As the program proceeds, it draws progressively smaller and smaller circles at different angles with respect to the center of the previous circle. until the diameter is less than 1. At this point, the subroutine at 0111 will finish and the previous values will be retrieved or popped off the stack and a second and third recursion drawn. Here's a way of visualizing what is happening. Imagine your circle and you are falling down a lift or elevator shaft. At every floor you pass, you get smaller and leave a copy of yourself at a position on the perimeter of the circle at the previous level until you reach a certain size. At this point you bounce back up one floor, increase in size, shift sideways to a different shaft, drop down again, decrease in size, leave a copy of yourself, then do this one more time. These are lines N450 to N480. After line N480, the routine returns and the code continues at line N280. The previous values are popped off the stack and O112 is called again since the parameter 3 circle diameter popped off the stack is not less than 1. Is your brain overheating yet? This is still not the end of the story, since this is only one limb of the recursive tree. There are more recursions until all of the subroutine returns have been exhausted and the subroutines finally unwind. Now fix parameter 3 or 0 is of special interest. It turns out that in Mach 3 post-processor, any value, positive or negative, odd with 0, will result in the value 1. For example, 64 or 0 equals 1, 0.5 or 0 equals 1, even -9 or 0 will result in 1. However, 0 or 0 will result in the value 0. Now fix x will round x towards 0 so that fix 12.8 equals 12, fix minus 3.14159 equals -3. This means that when parameter 3, the circle diameter, remember, holds the value 0.5, fix parameter 3 or fix 0.5 will result in 0. Therefore, 0 or 0 equals 0. And a subroutine with an L parameter of 0 will not run and will simply drop through. You can have fun by changing the start parameters or try the following. Try commenting out lines N450 to N480. Let's see what happens. Comment out lines N470, N480 and change N1110 parameter 7 equals 120 to N1110 parameter 7 equals 180 and see what happens. Try duplicating lines N470 and N480 immediately after the original 470 and 480. Then change the angle increment N1110 to #7 equals 90. You'll probably need to zoom in to see the results of this one. Also try putting line N260 just before line N360 and see what happens. Then try putting it just after N370. Now do not do all of the above together. Just do them one at a time or you'll get a right mess. Enjoy. Right, I've done a little animation here which may also help you understand what's going on. First we draw the base circle at 64 units diameter. Then at a different angle we draw one at 32, half the size. Then another one at half that at a different angle, half that size. So now we're down to 16. And we draw one at 8 units diameter. Go drop down again, draw one half that at 4 units. And drop down again and draw one at 2 units. And finally we draw a circle at 1 unit. Now we can't go any smaller than that, so we drop out of that routine and go on to the routine now at N460 and draw a circle at 1 unit, and then at N480 we draw another one at 1 unit. Now we return from that subroutine, retrieve the values and start again at 2 units diameter, then reduce the value to half that, draw one at 1. Now we're back out at line 460, draw another one, can't go any smaller than that, so we drop out and go to N480 and draw another one at 1. So that's that little recursion done. We're back out of 0112 and call again, calling subroutine, and encounter a circle at N440, back out of that one, retrieve the values, draw a circle at 1 unit diameter, and finally at N480 draw another one at 1, and that's that recursion finished. So now we have achieved this little pattern which is part of the final diagram. So we back out and we can see how far we've gone down the recursive tree. But this is only one limb of the whole diagram. There are many more to be drawn.